Determination of formulas. Common formulas used in chemistry include the empirical formula and the molecular formula. First, let's talk about the empirical formula. What is empirical formula? The empirical formula is the simplest whole number ratio of atoms of each element in a compound. It is a way to express the composition of a compound using the smallest possible integers, showing the proportion of elements present. What about molecular formula? A molecular formula shows the actual number of atoms of each element in a molecule. Example: glucose has a molecular formula of C6H12O6, indicating 6 carbon, 12 hydrogen, and 6 oxygen atoms. On the other hand, the empirical formula of glucose is CH2O. What does this really mean? It tells us that the ratio of carbon, hydrogen, and oxygen in a compound is 1:2:1. Hence, the empirical formula of glucose is CH2O. Let's talk about the importance or the uses of empirical formula. The empirical formula is useful for identifying the simplest ratio of elements in a compound, whereas the molecular formula shows the actual number of atoms in a molecule. For example, molecular formula of glucose C6H12O6, while its empirical formula is CH2O. Some key points about empirical formula. They are often used to identify unknown compounds. They can be used to determine the percentage composition or combustion analysis data. They can be used to determine the simplest whole number ratio of atoms. They may not show the actual number of atoms in a molecule. Let's talk about the key concepts or the key points about molecular formulas. Molecular formulas show the actual number of atoms of each element in a molecule. They provide more information than the empirical formula. They are used to identify the exact composition of a molecule. They can be used to calculate molecular weight and structure. They are often used in chemical reactions and synthesis. What is the relationship between empirical and molecular formula? From the formula, empirical formula multiplied by n is equal to molecular formula. The n in this formula represents the number of empirical formula units that make up the molecular formula. The n in the formula is a multiplier that represents how many times the empirical formula unit is repeated to get the molecular formula. For example, if the empirical formula is CH2O and n is equal to 6, it is very clear that the molecular formula is C6H12O6. Let's talk about the nature of empirical and molecular formula problems. Empirical formula problems can come in various forms, including, let's talk about 4 different cases. Case 1, given mass composition. Given the masses of elements in a compound, you can be told to determine the empirical formula. For example, a compound of nitrogen and oxygen is analyzed, and a sample weighing 1.587 gram is found to contain 0.483 gram nitrogen and 1.104 gram oxygen. What is the empirical formula of the compound? Let's talk about case 2. Given percentage composition. Given the percentage composition of a compound, you can be told to determine the empirical formula. Example 1. An analysis of sodium dichromate gives the following mass percentages: 17.5% nitrogen sodium, 39.7% chromium, 42.8% oxygen. What is the empirical formula of this compound? Another example. Benzoic acid is a white crystalline powder used as a food preservative. The compound contains 68.8% carbon, 5.0% hydrogen, and 26.2% oxygen by mass. What is its empirical formula? Let's talk about case 3. You can be given the molecular formula and you are told to find the empirical formula. For example, if the molecular formula of glucose is C6H12O6, what is the empirical formula? The last case, which is case 4. Combustion analysis. Given the masses of CO2 and H2O produced from combustion reactions, you can be told to determine the formula of a compound in terms of empirical formulas. For example, 3.87 gram sample of ascorbic acid contains only CH and O, and it gives 5.80 grams CO2 and 1.58 grams of H2O on combustion. What is the percentage composition of this compound? And what is the empirical formula? In the second part of the video, we are going to do some detailed calculations to all the problems presented in this segment. Do well to like this video, do well to subscribe, do well to share with your friends. This is Dr. Bennitex here, making complex chemistry concepts very easy.